Hello and welcome to our presentation. My name is Steven Martin Selvista, and today we are going to present about our final year project, which is flexural behavior of concrete beam containing barbed wire as confinement. My other group members are Kirsten Van Ang and Calvin Dainal. Our supervisor is Sir Dalmon Peter. Let's start off with the introduction. Concrete is the most popular building material in the construction industry. It is mainly used to build slabs, footings, and beams. But concrete has one major flaw in it. It is very brittle. Concrete is very high in compression but very low in tension, meaning it cannot withstand high amounts of flexural stress. So, we propose to use barbed wires as a confinement material to concrete. Next, we'll go to the problem statement. As I said before, concrete cannot withstand high amounts of flexural stress. If a concrete beam reaches its maximum stress resistance, the concrete beam will experience flexural failure. If this thing happens to buildings and structures, it can endanger the lives of civilians around that area. Next, we'll move on to the objectives of our research. The first objective is to determine the density and water absorption of concrete. Then, to determine the compressive strength of concrete. And finally, to determine the flexural strength of concrete. The compressive strength will be compared to the flexural strength because flexural strength is 10 to 20% of compressive strength.
For the research method, the methodology flowchart shows that we begin by preparing the materials for the concrete cube and beam, which is cement, sand, coarse aggregate, and water. And then we prepare the concrete mixing and water ratio according to the weight for 1 meter cube. Next, we work on concrete sample preparation, which involves tamping concrete and placing barbed wire after tamping. After that, we test for density and water absorption before curing, and later the specimen were placed in a curing tank for 28 days. Then we remove the specimen and test for density and water absorption after curing, which then we tested the compression test for cube specimen and flexural test for beam specimens. Finally, we analyze the data and make a report of this study. In our research finding, the result shows that the density and water absorption graph both had low value before and high value in after, which due to the water absorption by the beam specimen causing both density and weight of beam specimen to increase. The percentage of water absorption from 0 barbed wire until 6 barbed wire is decreasing due to the increase of density. In Table 1, the average compression strength is 18.23 megapascal, that in theory, the flexural strength is 10 to 20% of compression strength. In Figure 3, the highest average of flexural strength is sample with 6 barbed wire, which is 9.4 megapascal, while the lowest with 0 barbed wire, which is 4.4 megapascal due to the contribution of barbed wire. For the mode of failure, 0 barbed wire is relatively straight in flexural crack, 2 barbed wire slightly slanted in flexural crack, 4 barbed wire crack split into 2 branches in flexural shear crack, while the 6 barbed wire crack split into 2 long branches in flexural shear crack.
In conclusion, according to the data obtained from all the tests conducted to beam and cube specimen after 28 days undergoing curing process, we can conclude that the density of beam specimen is increasing. This is due to the additional weight of water absorbed by the beam. Beam specimen with 0 barbed wire are more dense than 6 barbed wire. Water absorption rate trendline shows a decrease, mainly because the increasing density of the beam specimen with 0 barbed wire to 6 barbed wire. The average compressive strength of cube specimen are 18.23 MPa. The average flexural strength of beam specimen tested are more than 20% of the cube compressive strength. Average flexural strength of beam increased from 0 Bob wire to 6 Bob wire. This shows that the installation of Bob wire contributes by increasing concrete beam's flexural strength. Moving on to suggestion, to ensure that the Bob wire can reach its full potential, it must be put in the tension zone of the concrete beam to increase its ductility and strength. Bob wire can also be applied in concrete slab. Using the same concept as the concrete beam, Bob wire can control and slow down the cracking rate of concrete, hence minimizing the damage.